welcome to another section of this course where we will build our circuit in EZEDA. So we're going to build our AC to DC converter, and in this case we'll finish up with sending this PCB to manufacturers to manufacture the PCB and so forth. So first of all, we need to open a new project. You click the file section and go to new project, and you'll be taken to this window. Name your project AC to DC converter. So you can name anything, just give it a name of your project. You can give the description of your project, how your project is doing, so that you can refer it back in the future. So let us just click save here, and it will load us to a new sheet. So in this sheet, we are going to put our components that will help us to design our circuit. So just a heads up, in order to come up with a good PCB, you need to do research of the components that you're going to use. So you are going to check the power constraints and whatsoever, simulate it, and come back here to design your PCB. So in my case, I've already picked up some components that are needed in this project. So the first component that I require is a AC input. So my AC input, I already have the model number, so I can just go to library and paste in the model number, press enter. So in this case, it's going to load the component that I'm looking for. As it will produce the component to me, and I will just need to select the component. So what I'm working with is it's an AC input. So make sure you place it on your sheet, select the component, place you just need to place space in order to connect to your component. So you can see that we do have a red dot here. So this red dot just shows us where we can place in our live power. So that's it. That's what it's saying. So next, what we need is a switch. So it's a good practice that you can switch your device on and off. So we just need to place in the switch. In order to do so, let's go back to library and paste in the model number of my switch. So I just press here, select, it will load, and place, then place in the component right on your sheet. Next, what we need is our transformer. So our transformer is the one that we use to step down in our section. So our transformer, we just need to place library and paste in the transformer's name and press enter. It's going to load the component of the transformer. Then we'll go to system. In this case, we'll go to system, and in this system we'll have our exact transformer. So we can just select this one and off we go. So we can place the transformer right here. Just on a side note, some of the components here you cannot find them on at the market, so make sure you do your research and to find your components. I'll actually show you a trick of how you can find that these components are available in the market or not as we go along. Then after this, we'll need a rectifier. So we'll check, we'll take our rectifier model number, we'll go to library and paste here the name of our rectifier. And once it's done, what we need to do is to just select the rectifier. So in this case, we just select our rectifier and off we go. So this is a chip that you place inside your circuit. After this, what we need to do is to put some capacitors. So you don't need to check capacitors online. What you need to do is to use the common library and check the electrolytes. Make sure you do not select the SMD. The SMD, they are fast, but they don't keep charge for a long time. If you are working with power supplies, you need to have the through hose because they do keep charge for a long time. You can appreciate this that you can check your power supply maybe for PC, and you can see there are big capacitors in there. So we'll place in 2 capacitors in parallel configuration. Then we go and search for a voltage regulator. So we do have a voltage regulator on this area. If you scroll down on the library, you do have a voltage regulator. We are using the 7805. So in this case, there are many configurations here. Just need to select the one that you want. So you can just select the bigger one here and place the voltage regulator, place it here, and we are almost done. We need to place in we need to search for a DC output. So go to library again and paste in the model number of our DC. So these outputs are just connectors that will actually place on our circuit in order to place in order to actually check in order to give an interface to the user to put in the to place in their DC components to get the power. So lastly, we just need to place in here our ground and our ground on both sides so that we can ground this circuit. So far we are almost done. The last part here is to connect the components. So we just need to place the wire to and connect the components. So I'll be back once I have connected all the components. And I am done connecting all the components. So in this case, I just need to cross-check in some areas and take note on this part. Take note on this part where the line looking like they have been crisscrossed, so that I can connect in the right port of the components. So once we have connected this, what we need to do is to go to design and place convert schematic to PCB. So it's going to load and check if there are errors, and will be taken here to our PCB. So there is a new window that is popping out. So this new window actually shows us the settings that we can change on our PCB. So the first one is the unit, and the second one is the copper layer. So we do have a copper layer of 34 layers in a PCB, but mostly we play around with the two layers. So our PCB is going to have 2 layers, which is the default on most cases. But if you are making sophisticated PCBs, you can have 34 layers of PCBs. I want to have a round PCB, and I'll apply this round PCB on my round rectangular PCB on my sheet, and I'll just play apply, and you can see that my PCB has changed shape to round. So in this case, what I need to do is to place these components. So basically it's try and error. You can change around, but make sure that it's good practice to separate your AC and DC components so that you can have less noise on your output. So in this case, I will just place around my components and make sure they are in the right configuration. So I can just change the orientation, and actually just press enter to change the orientation of your components. So in this case, so basically you can just change orientation in that, and make sure you place them correctly according to your liking. So I'll come back right after this and show you my configuration. And I am done working with arranging my components. What I need to do now is to connect the traces. So what I'm making now, it's permanent traces of my board. So in order to have permanent traces of my board, I need to go to track option here on this toolbar. I'll click that one and place it on a pad of a certain components to connect to another pad right here. So I'll click here and connect it right here. You can see that the trace is too small for AC input. So in order to increase that one, I will need to click the trace, go to the light section and increase the width to 1 millimeter. And in that way we can increase the trace. So make sure that your AC input has got bigger traces, unlike the DC input. So I'll connect it right here. Make sure that we do have powerful, bigger lines on our AC. So you can see that the trace is going to direct you once you click one pad to another. So in this case, that's how you can have you can connect two lines. Now there is something here. You can't connect the trace by passing another trace right here. You can't do that because in that way you create a short. So in order to do this, since these are through-hole components, what we need is to change our perspective and go to the bottom layer. So in order to do so, you go to this layer and objects and select the bottom layer right here. So in that case, we are looking at the downside of our components, and you can see that I'm able to place in my traces just like so. So once I'm done placing traces at the bottom, and I can switch back to the top layer and place the traces at the top of my board, and just like that we are done. So there are some other complications that come in with this just board, with just this orientation. You need to put a copper layer on the silk screen or on the surface of your board in order to ground your board to reduce noises. So in order to do so, we'll go here on our toolbar, PCB toolbar. We'll select our copper layer option, and you need to select the net to ground. So you say you are grounding the whole board. Select the outer part of the board in order to cover it. It doesn't matter the orientation, and release the cursor in such a way you have actually created a ground copper layer. So we'll go to the bottom layer. In order to go to the bottom layer, select the toolbar of layers and objects, select the bottom layer and place in the copper layer as well. So we just cover the whole board right here and release the cursor. So in such a way, we have actually created copper layers on both ends. You can visualize in that way. Now we are done designing our board. What we need to do is to save our board, Control S to save the board, and we need to visualize our board and how it's looking. In order to do so, we have two options here, 2D and 3D. Let's start with 2D. So on 2D, this is how your board will look like once it's been fabricated. So you can see your components, how they are placed. And on 3D, it's mimicking how your board is looking. It will look like when you have fabricated it. So you can see this is our beautiful board that we have designed so far. So you can actually visualize that we do have our AC input here, and we do have our voltage regulator right here, and our capacitors, and we are seeing that we do have our switch right here and our DC output. So this board, if fabricated and put it in action, it's going to produce exact amount of voltage that we have simulated so far in Matism. So let's go to another section where we will actually I will send this PCB board into fabrication. Now we are done with designing our PCB. We need to send this PCB to JLC PCB, and also take a look at how we can order parts of our PCB. So in order to do so, go to fabrication section, select BOM. So BOM is a bill of materials that we have placed on our PCB. So export the BOM file. It's going to prompt you to select, to show the data that you want to select. So this is enough. Let's export, and it's going to prompt you to save your BOM file on your PC, and I've just done that. I'll click cancel here, then go back again, press PCB and fabrication file, so the Gerber file, and it's going to show you that you need to check the DRC. So DRC is the design rule checking, to check if you have errors on your board depending on the constraints that you have placed on your board. So I will just press yes, check DRC, and once we are in this window, that means our board is good to go. So in this case, we just need to create a generate Gerber file, and it's going to prompt you again to save that file on your PC. Then let's go to JLC PCB. We'll click this button, and there is a pop-up window here that comes in on JLC PCB. Let me maximize the viewport. So I'm not yet signed in. I'll just click sign in here, and you can see that it has already signed in to my account right here. In this case, what I need is to place in the Gerber file. So you can see here that it's saying add Gerber. Once I place here, it will prompt me to where my Gerber file is, and I'll select my Gerber file. It's going to load, taking me to another screen, and that screen is going to load my Gerber file and process it, and I'll be able to view the Gerber file right in my viewport. This is exact Gerber file that I have placed, I have designed. So this Gerber file right here, it has got many options that I can change. I can change the dimension of the circuit. I can also change the layers. We have already done this in our software. I can also change the thickness of my PCB, the format, and the silk screen, and the color of my PCB. I can change it to black or even white. So depending on your budget, you can change in the color that are optioned for you here. You can change also the quality of your PCB, high specs and whatsoever, and gold fingers as well. So these ones, they are high spec PCBs or flying probe test. You can do that here and whatnot. But however, we just need to put leave it as it is. So you can also change the quantity of your PCB if you need lots of PCB. So you can see the quantity actually reaches 80,000 PCBs. So if you have designed your project, maybe your circuit, and you are saying that you want to deploy this into production, you can change the quantity, and you can go to 80,000. So if you have a budget of 13 over maybe near 14,000 US dollars, you can generate, you can actually place this order here. Now it's prompting us saying, please prototype PCB first, then use the reorder function for a small batch production. So it's giving us wonderful warning messages. So let's go to 5 here in order to prototype our PCB. Once you do that, you place in here save to cut. But before that, you can check the shipping estimate. You can see it's $60 to ship this PCB to Malawi, and you can appreciate here that this PCB will take 3 to 4 days in order to have the PCB, and 3 to 5 days to get the PCB right here in Malawi. But due to my experience, you can get this PCB within 4 days from China to Malawi. You place save to cart, and it's going to save your PCB to your cart. Let's go and view the cart, and you can see I do have 2 options here. So this one is my previous project, but let me delete that one. So you can see that it's in my cart, and I can proceed to secure checkout and place in my details that are required for me to order this PCB. So my details are my shipping address, my billing address, my credit card numbers. So basic things that you do, you place, you put in your softwares, maybe softwares that helps you to ship things online. So there are basic things that you can place in here, but otherwise, once you are done placing here, the only thing that you do is just wait for your PCB. Now let's go to placing our order for our parts. What you need to do is to go to LCS. There's a pop-up window here. It's going to load. It's going to load your account. So you can see my account is already loaded here. If you don't have an account, create an account. So on this website, I already told you that I will tell you a trick of ordering these components. So if we go here and go to bridge rectifiers, make sure you do your research before you press in the order. What do I mean? Check that this component is in stock. So you see that we do have 4,000 not 4,000, 149,000 plus components of full bridge rectifier. So if you click here, there's also a pop-up window here that shows the component if it is in Easy EDA model. So make sure you click here and you can check the component the way it's going to look in Easy EDA. So make sure that you get the model number of your component. So you can get this LCSE model number, and place it on your Easy EDA to grab this component so that you don't have any hassles of searching the components online. So make sure you do that before you place in the components on Easy EDA. So once you are here, just place, let's go back to our previous window. Just place the BOM tool and click select file. Just select the BOM file that you have on your PC and you'll be taken to this window. So in this window, what you need to do is just match the labels to the labels of the platform. So I'll just go here, select the quantity. I don't mind these other names that are here because you cannot find footprint here. But I'll go to manufacturer part and place in the part number, manufacturer. I don't think we do have supply or supply part or price. Then click select, and you can see on my BOM file only the AC input is what is available and it's in stock right here. So I did this deliberately to show you that if you just select your parts anyhow, they are not going to be found on your list. But if you do so, what you need to do is to just select the add to cart, and you are going to go to your cart right here and proceed to your checkout. So these are shipping options that you need to select. The Singapore Post, and make sure you calculate it well. Go to secure checkout and proceed same as ordering your PCB. So this is basically how you can actually have your PCBs and your components in Malawi and prototype cool projects. So anyway, it has been a wonderful journey with you guys, learning how to design PCBs and simulate them in your software. So please make sure you practice this and coming up with a new project, cool projects. I really want to see your projects here in Malawi, and make sure that you're solving problems that we are facing here. So make sure that we have something else tangible in Malawi. if all goes well, I will see you on the professional side of this course, where you can have multiple simulations and check errors of your PCB. So our next professional course, we will have this course in OTM designer and in materialism, where we can have complex circuits that you can deploy in real world projects. But anyway, this is enough to get you up and running and prototype your projects. So see you next time. Thank you very much.